You are welcome to the GMAT 41's YouTube channel. In this video lesson, I want to quickly teach you what the domain of a function is. The important conditions that a number must satisfy before you say that that number is part of the domain of a function. And of course, I also want to show you something about the brackets used when quoting the domain of a function and what the brackets represent, what it actually means. To start with, I'd like to define what the domain of a function is in much simplified format. The domain of a function is simply the set of real numbers which, when substituted into the function, will give you another real number. The set of real numbers, we can use x to represent them, which you are going to substitute into the function. This set of real numbers are called domain if, when you substitute them into the given function, you get another real number. The other real number you get is called the codomain of the function. Now, I want to believe that you understand what domain now is. If I give you a function and I give you set of real numbers, how can you identify the real numbers that are part of the domain of this function? At this point, it is now time to talk about two important conditions that a number must satisfy before you can say that that number belongs to the domain of the given function. Condition number one: the number must be a real number. So for you to say that a particular value, a particular number is a domain, it must satisfy the condition that this number is a real number. I know we may be wondering, our numbers, are they not real numbers? Okay, as you go through our playlist, you'll find out a video lesson on types of numbers. And you'll come to see that generally our numbers are divided into two: real numbers and complex numbers, also called imaginary numbers. It is important for you to know that the domain of a function is not imaginary number, it's not a complex number. Rather, it is what? A real number. And when we talk about real numbers, what do we mean? They include natural number, integers, rational numbers, irrational numbers. When you come to natural numbers, there we have even numbers, odd numbers, prime numbers. Please, for more detailed understanding of what these numbers are, I urge you to search through our playlist and you can see the video lesson on types of numbers. However, below this video lesson, in the description section and also the comment section, I have the link to this video lesson on types of numbers, so that whenever we say that domain must be a real number, please take note of all the numbers that we refer to as real numbers. Condition number two: for us to refer to a real number as belonging to the domain of a function, as being part of the domain of a function, this real number, when you substitute it into the given function, the answer it should give to you, or the answer you expect to get, must be a real number also. What do we mean by that? Imagine I give you a function, say y is equal to 2x all over x plus 1. Any value of x, which is a real number, that you think should be part of the domain. If actually this real number is part of the domain, it must satisfy condition number two, which is, if you pick that real number and you substitute it into the function, 2x all over x plus 1. The answer you get is expected to also be what? A real number. Now, once any number satisfies these two conditions, you can now smile and say, yes, this number is actually part of the domain of this given function. So, dear friends, I want to believe that you get the whole idea of what the domain of a function is. In summary, two conditions must be satisfied. Number one, the domain of a function must be a real number. Number two, the domain of a function, when substituted into the given function, must be equal to another real number. Now, in the study of functions and relation, when we talk about domain specifically, there are certain brackets we use. And I'd like you to take a look at the bracket. One of the brackets is this, brace. This is when you write the domain of a function in a set notation form, just like we deal with under set theory. So we use this brace bracket. If you're writing domain in interval form. The next, we can use square brackets, either this or this. When we use this bracket, it carries a special meaning. It carries a special meaning. For example, if I have open brackets, okay, and then I write, let us say, -3 here, okay, this simply means that -3 is the starting point and also part of the domain of the function. Is that okay? Now, if I close a bracket with something like this, let me say, let me say 7. This simply means that 7 is the end point, the last value of the domain of the function, and that 7 is part of the domain. So anytime you use this bracket, please take note that the number which you write in there, they are part of the word domain. The next bracket you see when dealing with domain, another bracket you can use is this one. Okay, now this bracket, whenever you use it, it simply shows that that number which you write there is not part of the domain. Is not part of the domain. However, it serves as a boundary. It serves as what? A boundary. So, for example, if I write, let us say, -3, this would be open, the starting point, okay? Good. But this -3 is not part of the domain. So if I have -3 and the number is increasing, if I decide to start with -3, using this bracket, this curved bracket, it means that -3 is not part of the domain. It's just serving as a boundary. Does that make sense? So the values could actually start from something like -2, okay, just a number that is greater than -3, and then go on. Again, if you close your bracket with this, let us assume I have something like 7. This is still a curved bracket. Once again, it shows that 7 is not part of the domain of the function. Rather, this 7 is the end point, serving as a boundary. Are you following, right? To what the set of elements that belongs to the domain of the function is. With this thing I showed, let me assume I give you something like this. -2, +2. This simply means that the domain of a function are all set of real numbers starting from -2. -2 is inclusive, and then increasing up to +2, it will stop. So anything outside -2, like -3, -4, anything above +2, like 3, 4, 5, 6, they are not part of the domain. The domain are the values between -2 and +2, then -2 and +2 also inclusive, also part of the domain, because of this square bracket that you used. But take a look at this. If I have, open a bracket, this is a curved bracket -2, 2, and then I close like this. This shows that the domain includes all sets of elements just greater than -2. Here, this curved bracket, okay, shows that this -2 is not part of the domain. The set of elements that forms the domain are the elements between -2 and +2. Now watch, -2 is not part of it because of this curved bracket. Then coming to this, +2 is part of it because of this square bracket. So that's just the interpretation, are you following, right, of the concept of these types of brackets used whenever you want to quote the domain of a function. No wonder anytime we use something like infinity, maybe if you are dealing with real numbers, negative infinity and positive infinity, let us assume that you have a function and the domain of the function is all real numbers. All real numbers can be written using negative infinity and positive infinity as our boundary. And so we could use this bracket. It means that the domain is set of all elements between -infinity and +infinity. -infinity is not part of the domain, +infinity is not part of the domain, of course, because infinity is not a number. So in this case, this infinity, because of this bracket, curved bracket, it means that that infinity is just a boundary. Are you following, right? So it is only the numbers between them that form the domain of a function. I want to believe that with this explanation, you've gotten as much as 98% knowledge of the domain of a function. Yes, because solving for the domain of a function is not the problem. I believe the problem is quoting the domain. Yes, you will get to understand this in my next video as we pick questions to solve on how to obtain the domain of a function. Because when the question is given to you to find the domain of a function, you don't start testing real numbers to know the one that you will substitute into the equation or function to get another real number. You don't do all this continuous substitution. There are shortcuts, let me use that word, okay? There are tricks, there are principles, there are procedures that we use to quickly get what the domain of the function will be and which number will not be part of the domain. In our next video lesson, I will be teaching you that, and I urge you to follow us at GMATS 41 as we carry you along in your studies. If this is your first time of visiting the GMATS 41's YouTube channel, please like and subscribe to my YouTube channel. You can leave your comments, share these video lessons to your friends, okay? And if you have any question, feel free to drop it in the comment section. I'll be right there to respond to you. And if you're a returnee and you have not subscribed, please, what is holding you? Kindly subscribe. From my YouTube channel, GMATS 41, as you go through it, you would find out that there are so many things you can learn. In fact, there is no end to what you stand to benefit from the GMATS 41's YouTube channel. So I'm appealing to you, friends, please kindly subscribe, like, and share the GMATS 41's video lessons. And of course, invite your friends and encourage them to subscribe to this channel also. And please, remember, if you are in Awka, Anambra State, and specifically if you are a UNIZIK student, you can join our physical class tutorials on campus. Contact the GMATS 41 on the number showing on the screen in order to get vital information on how to join our physical tutorial classes, where we cover so many other courses. I'll be seeing you in our next class. But don't forget what we've learned so far. What is the domain of a function? Real numbers, which when substituted into a given function will produce what? Another real number. What are the conditions that a number must satisfy before you say that this number is part of the domain of a function? Number one, the number must be a real number. Number two, the number, if you substitute it into the given function, it will produce another real number which we call the codomain. Then we concluded by talking about the three different types of brackets usually used when quoting the domain of a function. We use the brace bracket, we use this square bracket, and we use this curved bracket. And I interpreted the meaning of these bracket symbols as used in domain. See you in our next class.